A 5 why root cause analysis is a fast, simple method that stops recurring problems by digging past surface symptoms to find the core issue. Instead of using temporary fixes, teams ask why 5 times to find the real breakdown in a process and fix it for good. A root cause analysis, or RCA, is a structured problem-solving method used to find the core, underlying reason for an issue or failure. Instead of just fixing surface-level symptoms, RCA aims to permanently solve the main problem, so it never happens again. One such type of root cause analysis is the 5 why. The 5 whys framework is a simple problem-solving technique that helps you identify the root cause of a problem by asking why 5 times or more. Instead of addressing surface symptoms, this method pushes you to dig deeper until you uncover the fundamental issue causing the problem. The 5 whys technique helps teams move beyond quick fixes and surface-level solutions by identifying the root cause of a problem. When something goes wrong, our natural response is often to address the immediate issue and move on. A server crashes, so we restart it. A customer complains, so we offer a discount. A deadline is missed, so we work overtime. While these actions may resolve the immediate situation, they often address the symptoms rather than the underlying cause. The 5 whys helps uncover systemic issues that, when left unresolved, can lead to recurring problems. The process requires minimal time and resources compared with more complex analytical methods, yet it can be applied to nearly any type of problem. Most importantly, by identifying and addressing root causes instead of simply treating symptoms, teams can develop lasting solutions and prevent problems from happening again. Use the 5 whys to transform we keep having the same problem until we identified and fix the actual cause. Whether you are troubleshooting production issues, investigating project delays, or determining why customer complaints continue to occur, this simple framework encourages teams to move beyond temporary fixes and implement meaningful, long-term solutions. The power of the 5 whys lies in its simplicity. You do not need specialized training, expensive consultants, or lengthy analysis sessions. What you need is the discipline to keep asking why, until you reach the underlying issue. By doing so, teams can replace band-aid solutions with effective corrective actions that address the problem at its source. The 5 whys technique was developed by Sakachi Toyoda, founder of Toyota Industries, in the 1930s. It became a cornerstone of the continuous improvement leg of Toyota production system, the methodology that revolutionized manufacturing and laid the foundation for lean thinking. Toyota recognized that most production problems had deeper causes than what appeared on the surface. Rather than reacting to each incident individually, he developed a systematic approach to uncover underlying issues that, once addressed, would prevent multiple problems from recurring. The method's brilliance lies in its simplicity. You don't need specialized training, expensive tools, or complex frameworks. Just a clear problem statement and the discipline to keep asking why until you reach the real cause. The 5 whys method follows a simple but powerful process. Begin by clearly identifying the problem, then ask, why did this happen? Record the answer and use it as the basis for the next question. Continue asking why until the answers no longer reveal meaningful information. At that point, you have typically reached the root cause of the problem. The technique is intentionally iterative. Each answer leads to the next question, creating a chain of cause and effect relationships that takes you from the visible symptom to the underlying source. Think of it like peeling an onion. Each layer you remove reveals another layer beneath it until you reach the core. The real value of the 5 whys is that it prevents teams from jumping to solutions before they fully understand what went wrong. By continuing to ask why rather than stopping at the first reasonable explanation, teams are encouraged to look deeper, challenge assumptions, and identify the factors that are truly responsible for the problem. One important point to remember is that 5 is a guideline, not a strict requirement. Some simple problems may require only 2 or 3 whys to identify an actionable root cause. More complex problems may require 7, 8, or even more questions to uncover the underlying issue. The objective is not to ask exactly 5 questions as if following a set formula. Instead, the goal is to continue digging until you identify a systemic cause that can be addressed and corrected to prevent the problem from happening again. You will know you have gone deep enough when asking why. One more time simply repeats an answer you already received, leads back to an issue you have previously identified, or fails to provide any meaningful new information. This is your indication to stop investigating and shift your focus toward developing and implementing effective solutions. Not every 5 whys analysis follows a single, straight path. Some problems have multiple contributing factors, requiring teams to decide whether a linear or branching approach is more appropriate. Linear analysis works best for straightforward problems where there is a clear chain of cause and effect. One problem leads to a specific cause, which leads to another deeper cause, eventually identifying a single root cause. For example, if a website goes down because a server crashes, the server crashes because it runs out of memory, and the memory issue is caused by a memory leak in recently deployed code. The analysis follows a clear path from the symptom to the root cause. Branching analysis is more appropriate when several factors contribute to a problem at the same time. If asking the first why produces multiple valid answers, each contributing factor should be explored separately to understand how the causes interact. For example, if project deadlines continue to be missed, the analysis may reveal several contributing factors, such as changing requirements, limited testing resources, and unclear approval processes. Each factor may require its own series of why questions. When a problem begins to branch into multiple causes, consider using another technique like a 3-legged 5-why or a fishbone diagram to organize and visualize the different paths. This approach helps teams understand how various factors connect, identify relationships between causes, and ensure that important contributing factors are not overlooked during the analysis. A root cause analysis is not typically a solo event. It takes a team. A root cause analysis team is a small, multidisciplinary group that investigates systemic problems or failures. The key roles on an RCA team generally include team leader or facilitator. They guide the meeting and process, keeping the group focused, and ensures the tools and methods are used correctly. Subject matter experts or SMEs. These are specialists on the system or process that failed to perform as designed. They provide deep technical or theoretical knowledge about the specific system or machine involved. Process owners and frontline workers. They bring and share real-world insight because they work hands-on with the process every day. Quality assurance and/or safety representatives. Depending on the nature of the incident, it may be valued to have these positions available. A quality assurance rep may provide insight of the finding or nonconformance if the issue, especially if it was identified during an audit. Similarly, if the core issue was safety-related, then having a safety rep may provide value on the requirements or standards during the process. Data analyst. They collect logs, metrics, and timelines to back up findings with hard facts. Depending on the complexity of the analysis, it may be beneficial to have a recorder or scribe who documents the findings, maps out timelines, and captures the brainstorming and evidence, ensuring a thorough record. The next step is to prepare to lay the foundation. Like any structure, without a solid foundation the process will crumble. Key elements include: define one specific problem to analyze. Gather baseline evidence such as logs, metrics, records, and documentation. Set a time, place, and limit. Schedule a meeting so that all participants can plan to attend. Hold it in a space appropriate for the needs of the analysis with the table space, chairs, audiovisual equipment, dry erase boards, and whatever else that will be needed. And set time limits on the meeting based on the complexity and importance of the issue. And choose a neutral facilitator to guide discussion without dominating it. There are some important considerations to keep in mind during the analysis session. First, start with the problem statement. Write it at the top of a dry erase board and read it aloud. Make sure everyone agrees on what is being analyzed before diving into discussions and questions. Create a blame-free environment. Focus on systems and processes, not people. When people feel safe, they share openly. Ask why did this happen rather than who did this. Document the process. Sticky notes can be used to outline a process or for each why question and answer. This makes it easy to rearrange if it is needed to branch the analysis. Everyone can add notes simultaneously rather than waiting for one person to type. Use different colors to distinguish questions, answers, and evidence. Validate each answer with evidence. Ask, how do we know this is true? Reference specific data, logs, or documentation. Add supporting evidence directly to the board, upload screenshots, embed links, or connect to related boards. If evidence can't be found, pause and investigate before moving forward. And watch for branching. When one why produces multiple valid answers, create separate sticky note clusters for each path. For complex branching, consider switching to a fishbone diagram format. Now let's get into the process. Initiating a 5 whys analysis begins with Step 1. State the problem clearly. The foundation of a root cause analysis is a clear, specific problem statement. Vague problems produce vague root causes. The problem statement needs to be concrete enough that everyone on the team immediately understands what went wrong and can verify whether it's been fixed later. A good problem statement typically includes who, what, where, when, and how. And through the root cause process, you will work to identify the why. Make it specific, not general. An example of a bad statement is the pump failed. A better statement would be on August 14th, feed pump number 3 shut down unexpectedly, causing a 4-hour total loss of production on line 2. The first statement could be any pump, or maybe the assumption that it is all pumps have the same issue. The second statement provides specific clarity on the who, what, where, and when. Then the team can work to determine the why. Here is another example. The software training program is bad. What do you think? Does this provide sufficient information to start analyzing the process? Obviously no. A better version would be customer support calls have increased by 38% since the launch of version 2 of the new RCA software on March 1st, requesting help in system setup. Here the reason the team has been assembled can be understood, so they can focus on addressing the true problem. Step 2. Ask the first why. The first why requires turning the problem statement into a question asking, why did this happen? Why did this problem happen? Write down the answer based on facts, not assumptions. Here is an example. Problem. Patient B received a double dose of medication on August 18, 2026. First why would be, why did the afternoon nurse give the second dose? Next, step 3. Validate with evidence. Before moving to the next why, verify the answer with data. This is what separates an effective analysis from speculation. Without evidence, the analysis can easily drift into assumptions, office politics, or convenient narratives that feel true but don't actually reflect reality. Evidence comes in many forms, such as system logs, timestamps, error reports, performance metrics and analytics, documentation and project records, customer interviews and support tickets, and direct observations. The key is that the evidence should be verifiable and specific, not based on I think or it seems like. See the difference. An assumption would be sales dropped because the team wasn't motivated, versus evidence-based like sales dropped because we had 40% fewer demos scheduled, according to our CRM data. When you can't find evidence, pause. Don't move forward with unverified claims. Take time to investigate, gather data, or acknowledge uncertainty. It's better to admit you don't know than to build your entire analysis on shaky assumptions. One such method of collecting evidence is a Gemba walk. A Gemba walk is a management practice where team members physically go to the front lines, where the actual work is done, to observe processes, gather evidence, and talk with employees. Originating from the Japanese word Gemba, meaning the real place, its goal is to learn and understand operational realities rather than rely on second-hand reports. Here is how to conduct a Gemba walk. Plan the focus. Pick a specific theme or process line to observe before heading out. Observe quietly first. Watch a full cycle of work without interrupting or addressing things immediately. Ask open-ended questions. Inquire about what the team is not sure of or need clarification on by asking questions. An open-ended question is one that requires more than a yes or no answer. And follow up. Document the observations and information learned. Step 4. Keep asking why until you find the root cause. Take the answer from the previous why and ask why that happened. Keep building the chain of causality. This is where the method really tests patience. It's tempting to stop at the first answer that sounds reasonable, but the first answer is often just another symptom in disguise. Following the previous example, if the answer to why did the afternoon nurse give the second dose is that she did not see that the morning nurse already gave the medication, then the second why would be, why didn't the nurse see the morning dose? The answer is found to be, the electronic chart on the mobile workstation did not show the updated administration time. Why 3. Why didn't the chart show the update? Answer. The system failed to sync the morning shift data before the nurse logged the new round. Why 4. Why did the system fail to sync? Answer. The shift change data transfer script experienced a lag and required a manual refresh. And why 5. Why was a manual refresh needed? Now we are getting to the root cause. The hospital electronic medical record workflow lacked an automated real-time trigger during shift handovers. You know you have reached the root cause when asking why again doesn't produce useful information. The answer points to a process, system, or policy issue. The team agrees this is the fundamental issue. The team can imagine a concrete solution that prevents recurrence. In the example, if the root cause is because the nurse forgot, you haven't gone deep enough, ask why the system allowed the nurse's memory to be the only safeguard. Step 5. Develop and implement the solution. Now, brainstorm solutions that address the root cause directly, not the symptoms. If the root cause is no process for adjusting timelines when requirements change, don't just tell the team to be more flexible or communicate better. Those are vague directives that address symptoms rather than creating systemic change. Create concrete action plans. Define specifics. When requirements change, who gets notified? Who adjusts timelines? How are changes communicated? Assign clear ownership. One person accountable for implementation. Set deadlines. Implement by a specific date. And schedule follow-ups. Review in 30 to 60 days to verify it worked. Example for the app delay. Root cause. No electronic medical record automated real-time trigger during shift handovers. Solution. Install an automated real-time trigger to occur shift handovers. Owner. Director of IT. Timeline. Within the next 3 months. Follow-up. Test the system before full implementation. It should be noted, in this example, an interim immediate action will need to be put in place before the full corrective action is implemented. To learn more about the corrective action development and implementation process, click the subscribe button and watch the FSTG corrective action video. Here is another example of the process. The problem is a robotic welding machine on the factory assembly line suddenly stopped mid-shift. For the 5 whys chain. The first is, why did the machine stop? Because the circuit overloaded and the fuse blew. Why 2 is, why was there an overload? Because the mechanical bearings were not getting enough lubrication and locked up. 3. Why were the bearings not lubricated? Because the internal oil pump was not circulating enough oil through the system. 4. Why was the pump not circulating oil? Because the pump intake was clogged with metal shavings. And 5. Why was the intake clogged with metal shavings? Because the oil pump was installed without a metal strainer/filter to catch debris. So for the problem of the robotic welding machine on the factory assembly line suddenly stopping mid-shift. The root cause is a missing filter in the pump design allowed debris to ruin the lubrication cycle. And the corrective action is to install a mesh strainer on the oil pump intake and update the standard assembly blueprints so it never happens again. Here are some tips for after the session or sessions are completed. First, test the root cause. Ask, if we fix this, will the problem stop recurring? If the answer is yes and the team agrees, you found it. Document everything and save the information in case the problem resurfaces or a similar issue is realized somewhere else. Record the full analysis chain, supporting evidence, and any branches explored. This creates a record for people who weren't there and helps track whether your root cause was correct. Share findings with context. Oftentimes it will be useful to generate a summary report. However the process is quantified, use it to send the information to the broader team. Add narrative about what was discovered and what actions are being taken. Create concrete action plans. Define specific solutions, not vague commitments like improve our process. Assign clear ownership. Set defined deadlines. And schedule follow-up reviews in 30 to 60 days. And track effectiveness. Monitor whether the problem recurs. If it does, that's valuable data. It means the root cause identification was incomplete or the solution didn't adequately address it. Use that information to refine understanding and try again. Another version of this method is the three-legged 5 why, or 3x5 why. Instead of asking why 5 times down a single path, why is asked 5 times across 3 distinct tracks: the occurrence leg to assess why the failure happened, the detection leg, why quality controls missed it, and the systemic leg, why policies or management systems allowed it. Leg 1. Occurrence, the technical cause. Focuses on the physical, mechanical, or process failure that generated the defect. Ask why did the physical failure or error happen in the process? Leg 2. Detection, the control failure. Focuses on why the quality filter, inspection, or sensor failed to catch the issue before it moved downstream or reached a customer. Ask why did the checkpoints or testing procedures fail to notice the problem? And Leg 3. Systemic, the management or policy cause. Focuses on the overarching company guidelines, training gaps, or structural systems that permitted the condition to exist or recur. Ask why did our standard systems, training frameworks, or policies allow this risk to persist? Catching hidden gaps. Uncovers why a defect slipped past quality checks, even if you cannot stop the initial physical failure. Fixing systemic flaws. Reaches past local mechanical errors to expose broken management systems, training deficits, or cultural habits. Avoiding linear blind spots. Stops teams from forcing complex, multivariable incidents into a single, oversimplified straight-line narrative. Driving teamwork. Brings different departments together since detection and systemic legs often involve groups outside the immediate work area. And stopping repeat errors. Delivers 3 separate root causes per incident, ensuring you fix the trigger, the safety net, and the underlying workplace environment. There are times when to use the 5 why method and times to select another technique. The 5 why shines when the problem is simple to moderately complex and has a likely dominant cause. Whether a website crashes, a project misses a deadline, or customer complaints suddenly increase, these situations often have one primary root cause that, once addressed, can resolve the problem. The issue involves processes or daily operations. Problems involving people, handoffs, communication, or unclear procedures are well suited to the 5 whys. For example, why are reports consistently submitted late? Why do handoffs between departments repeatedly fail? Asking why helps uncover issues such as missing processes, unclear responsibilities, communication gaps, or conflicting priorities. The same problem continues to occur. If the team repeatedly applies temporary fixes to the same type of issue, it may be addressing symptoms rather than the underlying cause. The 5 whys encourages the team to investigate what is continually generating the problem so the organization can implement a lasting solution. An answer is needed quickly. When an issue occurs and the company needs to understand what went wrong without conducting an extensive investigation, the 5 whys provides a structured and efficient approach. In many cases, a meaningful analysis can be completed in less than an hour. You have a team with diverse first-hand knowledge. The 5 Whys works especially well as a collaborative exercise because different team members can contribute unique perspectives. One person may understand why development was delayed, while another may know why the delay was not communicated effectively. And the answers can be verified with evidence. The technique is most effective when the team can validate their findings using available information such as system logs, performance data, documentation, process records, or conversations with employees involved in the situation. Supporting each answer with evidence helps the team move confidently from the initial symptom to the actual root cause. It is also important to not use this system. Don't force the 5 Whys onto the wrong problem. This method isn't universal, and using it incorrectly wastes time and produces unreliable results. Here are situations when not to use the 5 Why method. It can oversimplify complex problems. When multiple factors contribute to a problem and interact in complicated or nonlinear ways, the straightforward questioning approach of the 5 Whys may overlook important relationships. A team may identify one root cause while failing to recognize other contributing causes that are equally significant. Results can depend on who is conducting the analysis. Different facilitators may ask questions in different ways, leading teams to reach different conclusions about the same problem. Without a consistent approach, this can make the 5 Whys less reliable than more structured analytical methods. Teams may stop at symptoms instead of reaching the true root cause. People naturally tend to accept the first explanation that seems reasonable. Without validating each answer with facts and evidence, teams may believe they have identified the root cause when they have only moved 1 or 2 levels deeper into the problem. It relies heavily on existing knowledge. The 5 Whys is most effective when the team has enough information to understand the problem. If the true cause involves an unfamiliar technical issue, an unexpected market change, or customer behavior the team has not yet observed, simply asking why may not uncover the answer. And it is important to remember the number 5 is arbitrary. Some problems may require only 2 or 3 questions, while others may require 10 or more. Because there is no universal rule for determining when to stop, teams may either reach a conclusion too quickly or spend excessive time analyzing the problem without making progress. When the 5 Why system will not be effective, there are other systems that may produce better results. Use these methods instead. Fishbone diagrams, also called an Ishikawa or cause and effect diagram, is a visual tool used to find the root causes of a problem. It looks like a fish skeleton, the head being the location of the problem, and the bones branch out to show different groups of causes. Use it when problems have multiple contributing factors that all need attention. Failure mode in effects analysis, or FMEA, is a step-by-step risk management method created by the U.S. military in the 1940s to find, rank, and prevent potential flaws or errors in a product, design, manufacturing process, or service before they cause harm or failure. It is best for high-stakes situations involving safety, regulatory compliance, or critical systems that require formal documentation. Fault tree analysis is a top-down, deductive method used in safety and reliability engineering to map out all the pathways and lower-level component failures that can cause a major system-level unwanted event or accident to occur. Use when analyzing system reliability or mapping multiple failure paths with probabilistic rigor. And comprehensive root cause analysis is a structured, in-depth framework used to identify the fundamental, underlying reasons for a problem or failure, moving past surface-level symptoms to prevent recurrence. An example would be using the taproot system. It is best used for when you need statistical validation, must prove causation with data, or deal with deeply interconnected organizational issues. Click the subscribe button to access videos on these methods. Though the 5 Why method is fairly straightforward and simple in its design, it is easy to fall into traps that can make the process ineffective. Common mistakes to avoid include: stopping at symptoms. The mistake is accepting the first plausible answer without digging deeper. An example of stopping too early is sales drop because leads decreased. Instead, keep digging. The leads decreased because our SEO ranking dropped. Because we haven't published content in 6 months. Because we eliminated the content team. because budget was cut without considering revenue impact. The fix is to always ask why at least 3 to 4 times even if an answer seems obvious. Let the process get you there. Another is relying on assumptions instead of evidence. The mistake is basing answers on opinions or guesses. An example of an assumption is customers aren't buying because our product is too expensive. One based on evidence would be customer survey data shows 73% cite lack of integration with existing tools as main barrier. The fix is to demand proof for each why. If you can't verify it, investigate before moving forward. Blaming people instead of systems. The mistake here is ending the analysis with someone forgot or person X made a mistake. An example of stopping at blame would be the deployment failed because the engineer forgot to run tests. Where one that examines systems would say because there's no automated testing requirement in our pipeline, because we haven't prioritized build automation, or because technical debt wasn't included in quarterly planning. The fix is that when you reach a person, don't stop, ask why did the system allow this to happen? Using 5 whys for complex problems. The mistake is forcing a simple tool onto multifactorial issues. An example of when it may be the wrong tool is when using to answer why did our company culture decline? This is likely a complex problem with too many factors to identify through a 5 why. Here use the right tool such as employee surveys, focus groups, and a comprehensive cultural assessment. The fix is to recognize when to switch to more robust analysis method. Accepting first answer without challenging. The mistake is not exploring alternative causes. Example: after why did the server crash? The answer is because of high traffic. It would be wrong to just accept it and moves to next why. Instead, challenges it. What else could have caused it? Could it be memory leak? Configuration issue? Let's verify with logs. The fix is to ask what else could have caused this before moving forward. Analyzing without implementing. The mistake is completing thorough analysis but never fixing the root cause. The fix is to recognize that the analysis is worthless without action. Assign owners, set deadlines, and track results. And lastly, not validating solutions worked. The mistake is assuming the problem is solved without checking. The fix is to schedule follow-up 30 to 60 days later to verify the root cause was correct and the problem hasn't recurred. And finally, here are some best practices to increase the potential for reliable results when performing a 5 why analysis. Focus on processes, not people. When you reach someone forgot or person X didn't do something, you haven't gone deep enough. Ask why the system allowed that person's memory or judgment to be the only safeguard. Maybe there's no checklist, no automated alert, or no clear ownership. These are systemic issues that prevent problems regardless of who's doing the work. Validate every step with evidence. Your analysis is only as good as your evidence. Logs, timestamps, records, metrics, documentation, and direct observations all count. I think or it seems like do not count. If you can't verify an answer, pause and investigate. Building a causal chain on assumptions is like building a house on sand. Don't force exactly 5 whys. Stop when you reach an actionable root cause that will prevent recurrence. Some problems need 2 or 3 iterations, others need 7 or 8. What matters is reaching a systemic issue you can actually address, not hitting a magic number. Involve people with first-hand knowledge. You need team members who have direct knowledge of the process, witness the problem, understand the systems affected, and can implement solutions. A room full of managers who haven't touched the work in years produces theoretical analysis. The right mix depends on your specific problem. Test your root cause before committing. Ask yourselves, would fixing this actually prevent recurrence? Does the whole team agree this is fundamental? Can we implement a concrete, measurable solution? Does the causal chain make logical sense? If you get hesitation on any of these, keep digging. And document everything. Record each question and answer, capture supporting evidence, identify the root cause clearly, outline proposed solutions with specifics, and assign action owners with deadlines. This creates organizational learning and accountability. Conducting a 5 whys root cause analysis is crucial because it stops teams from fixing surface-level symptoms and forces them to find the true underlying source of a problem. This simple questioning method prevents issues from happening again, saves time, and builds a better work system. We hope you found this training valuable. We recommend that you share the video with personnel who participate in your root cause analysis processes to ensure everyone understands this root cause analysis process. Please click the subscribe button to access additional FSTG training videos.